Hey, hello everyone. My name's Ethan Walz, and today I'm going to do a presentation on creatine monohydrate. I chose this topic. I was a bit inspired by the last presentation on protein. I enjoy working out and gym talk. So I learned a lot from that presentation. So figured maybe I could study a little bit about creatine and learn something interesting. I guess there's varieties of different creatines. So today we'll just talk about the most common creatine, which is the monohydrate. So what is creatine? Here we can see creatine is made up of three amino acids that are naturally found in the body, L-arginine, glycine, and L-methionine. Um, Pretty interestingly enough, it is 95% of it is found in the skeletal muscle. And there's even 5% that is found in the brain, kidneys, and the liver. Today, we're going to not only talk about the creatine that's naturally found in the body, but focus more on supplemental forms of creatine. So adding creatine into your body. Why creatine, or why do people supplement creatine? There are many reasons. Here I've listed a few. We can see that it supports muscle energy, supports muscle recovery. It can enhance strength, right? Working out, strength lifting, overall exercise performance. So football players or any other kind of sport that requires more energy than normal, I guess you could say. And there's even not so much research, but or not too much evidence, I could say, but maybe suggestions that it supports antidepressants, brain health, and skin health as well. Interestingly enough. Um, but how does creatine work, right? Creatine in action. So creatine is most oftenly absorbed into the skeletal muscle, as I said, 95%. And as it is in this process, it is changed into a phosphocreatine, right here, as phosphoric acid is added. Okay, this happens through an enzyme that is found in your cells in your body called creatine kinase. It is kind of like a creatine transporter, also known as a creatine shuttle. And this phosphocreatine can then be used to support ATP. So we'll talk a little bit more about what ATP means, what it is, and how it works in our bodies. ATP is known as ATP, but it is called adenosine triphosphate. It is a high energy compound or molecule produced in the mitochondria of the cells that gives ultimate energy to the cells in your bodies or your muscles. Here we can see the cellular um, formation of ATP, right? We have three phosphates right here. And these three phosphates, they have three negatively charged oxygens, which makes it they make them very weak bonds. With these weak bonds, when they come in contact with water, H2O, these one of the positively charged hydrogens will oftenly formed with the triphosphate bonds will form with this oxygen, and one of the phosphate bonds will break off from the triphosphate bond. In return, we are left with something called ADP, right? Very, very similar. We have ATP, which is high energy. And then when it comes in contact with water, it breaks off, hydrogen bonds, and ADP is formed. Here in the bottom right, we can see what ADP looks like, right? Just like I said, we only have two phosphate bonds now, and we have the hydrogen atom that has bonded itself to the two phosphates. ADP is called adenosine diphosphate, right? Low energy compound. Now, how does creatine support or help within the production of ATP, the high energy bursts? So as we have ADP, which is very commonly found in the body because ATP only stands in its form for maybe a couple of seconds before it finds the water and creates ADP. So creatine, right, like I mentioned earlier, as creatine enters the body, it turns into a phosphocreatine, right, through that little creatine shuttle that I mentioned. Kinase, I think, creatine kinase, I think it was called. But phosphocreatine, right, as hinted in the name, has a phosphate, okay? And so this phosphate is then given to ADP, right, as we can see in this bottom, which only has two phosphates. Therefore, the third phosphate, or the phosphate from phosphocreatine, bonds with the two phosphate, or the phosphate compound in ADP, which then turns ADP back into ATP, right, which has three phosphates. Okay, so it's kind of like a cycle, right? We have ATP, forms with water, breaks off, forms ADP, and then creatine in the system turns into phosphocreatine, and then the phosphate bonds with ADP, which only has two, making three, which is ATP, right? And ATP is the high energy compound, remember, and then ADP is low energy compound. So when, for example, if we're lifting heavy weights, we're strength training, and we really only need a couple seconds of strength to push the weight, ATP is going to be more useful, right? That is high energy. So very easy correlation, right? More creatine equals more storage for ATP to form. Hope that makes somewhat sense. This little chart here has helped me a lot. So not only does creatine support the production of ATP, but it also forms something called muscle cell volumization, which is pretty much just when the cells in your muscles increase in volume due to the absorption of water. So let's go back and talk about that creatine kinase, which is the creatine shuttle of creatine through your body where it turns into phosphocreatine. This creatine kinase is known as a sodium-dependent transporter. And this sodium-dependent transporter attracts water as it is transporting creatine. And this attraction of water is what causes creatine to, let's say, absorb water in the muscles or in the cells. And that is why people, or that is why you might look bigger when on creatine, or you might gain slightly bit more weight due to water retention, which is just called volume or muscle cell volumization. Now, what are some of the negative or just side effects of creatine, or some of the risks? Now, these four that I've listed are definitely reported and talked about, but there isn't any necessarily any evidence or thorough research to support these claims, but is known to help with weight gain, right? That water retention. It might cause diarrhea for some, sweating, or even some slight dizziness. So just be aware if you decide to start supplementing creatine. And that would be my next question: is creatine something that you would be interested in, or is it for you? And according to many people, many researchers and doctors, and experiments, it is known that creatine is one of the safest and most commonly supported supplements in the supplement industry, we could say. And that anyone who might be interested in performing better at physical sports, gaining weight, or even supporting their bodies or overall mental health might seriously consider supplementing creatine. It is oftenly loaded into the body, right, as you start taking it for the first time, to do so in a larger dose, which it's pretty much recommended to take as 10 grams a day for a week or so, 2 weeks max. And then after that week or two, to back off and start taking 5 grams a day when the creatine is more prominent in your body. So yeah, here are a few sources, and I hope you guys enjoyed. Thank you.